Okay, the live streaming's running.
Okay. As opposed to dead streaming? Okay.
Yes. Chris Allen is the expert for that.
Okay. By the way, Chris, you do appreciate I have fun giving these people a hard time. I do think it's good to mentor them. In any case, now that we're on the live stream, I'll let you talk. Is somebody in charge here? Hello?
No, there's no one actually moderating the Q&A.
By the way, I'm on
You start.
on this Microsoft microphone.
Historically, in the meetings, I would start around 10 or 15 minutes after. But
Okay. I'm curious which microphone is using.
we've only got 10 people right now. Usually we have a few more. I know that Ron Tebow was planning to come on, but I don't see him yet.
Okay, we can wait. We can kibitz. I can talk more about why C++ is not fit for human consumption.
Yeah, my first assembly language was IBM 360.
Yes. Which compiler? The H compiler, the G compiler, the F compiler, the assembler?
Probably, I don't remember which one I first used.
I mean, there are different things with different macro capabilities. But
Yeah.
Did you program switches by bashing the branch instruction and putting FF in or 00 in a low order nibble?
I used IEFBR14 a lot.
Oh, that was a library routine.
That's a library call.
No, that's a library call to return. Right?
The world's smallest program, and it has a bug, or it did. They actually patched it.
So it was a return. Well, BR14, you returned using register 14.
Return register.
Yes.
And it returned the address of the subroutine as its return code, so it always returned an error.
All it was a Baller instruction.
And they patched it so it zeros register 15 before doing the Baller. So it's twice as long as it used to be. And the problem is job control decks that the old way broke by the new one.
But yes, I remember the Basser instruction. Not many people use that one. That was Baller was a 24-bit. Basser was a 32-bit instruction. But remember, 24 bits. Who'd ever need a machine with more than 16 megabytes?
So what was like the earliest CPU to have an instruction to do division?
Oh, I don't know. Did Whirlwind have one? Maybe not. Did 650? Now the IBM 1620 didn't even do addition.
I learned on a 7044, and that was
yes,
basically a 32K machine.
No, and it was a big machine, and it had set parity bad instruction.
Yeah,
that's how they did what for.
Wait, if you didn't do addition, you just do some bit trickery?
In 1620, you'd look up the result. You take the two numbers and use it to generate the address where the result of the addition was. So it did arithmetic by table lookup.
The DEC PDP-8 that I worked on at school didn't have a multiplier quotient. And so any division had to be done in software.
I'm trying to remember. I think there was a divide instruction in the 6502, but to do any arithmetic more than 1 byte, you have to use a library.
Yeah.
But there are quirky machines, going way back then. But I think division was pretty early. 709, I bet you had it. Things I don't know.
But could be very slow microcode.
Well, what microcode in those machines? You're lucky.
That's how division entered, is when you had microcode.
No, I mean, there was. I mean, microcode was a much later idea.
You might
you
be
look-
surprised.
Well, I remember I mean, they're
You're never in doubt, but you could be surprised.
No, which machine would you think had early microcode? I mean, the idea came into currency, but the early machines like the SCS 930 had hardware designed for division, because we had the circuit diagrams. The 360, yes, had microcode, and that's why they invented the floppy drive to load all those processors. And then the IBM System 38 had what's called vertical microcode, which was probably an assembler interpreter to emulate the machine. We can look at who's been programming the longest. Who programmed the IBM 1620 here?
Yeah, before my time.
Yeah, I'm definitely older than you and Jerry. Younger than you and Jerry. I mean, you guys are older.
So all these machines. One of my greatest programming feats was a chance to program the IBM 407 in 1970. How many familiar with the 407? It was a plug board machine. And you had to optimize clutch cycles.
Yeah,
I
they
don't remember.
let me touch the plug board
Programming.
on those things.
What'd you say?
Operated a few of those, but they didn't let me touch the plug boards. Only Peggy could do that.
Okay. The plug boards are fun. I can talk about the 547, the 519, the 083. When I was a kid, no. When computers were computers.
No, I started. Oh, sorry. Go ahead.
No, you talk.
No, so I started in middle school. Actually, I think in my elementary school they had some Apple IIs. And I think they started us with that program that did the vector drawing.
Mm-hmm. Yeah. Okay, I don't remember which. I mean, I remember there was some vector stuff. We decided not to use InvisiCalc because it would just be add some more of too much more code.
Yeah, just the data structure for VisiCalc, like, was that like an array?
No, we actually had. I'm trying. We would actually allocate memory in chunks and then do garbage collection. So it wasn't an array. We had an array of pointers to the elements in the heap. So it was a heap.
Mm-hmm. And then, like, the function in the cell, was that like an instruction somewhere?
No, those are all stored as data, and we interpret them. What like when you say what kind of function, for example?
I'm thinking like a spreadsheet function where you say, okay, like add C2 plus, the number at A1.
Yeah, that would be stored as plus A2 plus C1.
Okay.
And PDP-8,
then,
What?
Oh, sorry, go ahead.
in PDP-8 in subroutine, the first line of the subroutine was actually the return address, where the return address would be stored.
Oh, they screwed that up.
So you'd branch to the address you branched to would actually be the return address when you use the subroutine branch.
So I take it this is what happens when you had Harvard people who never studied recursion or reentrancy.
I miss that.
In other words, if that doesn't work, if you have recursion or reentrancy.
Yes. Yeah.
So never let hard people design software. When are people going to learn that lesson?
No, and we actually did some interesting programming on the PDP-8. The Burger King point of sale system problem with PDP-8, and we did have concurrency, so we had to be quite careful.
Yeah, Dan Bricklin did a lot of that too. Except there might have been 11 by then, but yeah. I never I mean, I looked at PDP-8. I didn't do any PDP-8 programming. It was a cute little machine.
Yeah, I like the 8. I did a lot of programming on the 8 when I
And the
was in
tape
grad
drive.
school.
Yeah.
Got Bill Horn. Haven't seen Bill in a while. And Ron showed up.
I'm moving you up. So if you see me looking up, it's because you're now on the upper screen, so the slideshow can be on the lower screens. So then you just tell me when to start, or I have questions. I expect a lot of questions, so we'll see how far I actually get through on this. And opinions will be stated.
Okay, maybe another 5 minutes.
Okay. Get a little more water with it while I'm waiting for 5 minutes. Yeah. One thing this conversation made me think about, and I'll get into in my talk after I sneeze. No, maybe before I sneeze. It's terrible to want to sneeze but not do it. Is my food programming was really affected by the chance I got to programming the SDS 940 in 1966. So I went from programming where you were in Fortran programming to a complex real-time system with interactive users online and everything, providing data. And it changed my view of programming. I had to learn about operating systems, interrupt levels, and all sorts of things. And and it was hands-on hardware. You'd look at the circuits. Oh, like I wanted to add a store zero instruction. I saw exactly how to do it. I didn't actually do it, but it would have just taken one wire in the right place. I could have had a store zero instruction. So it really it's a different view of programming than if you just look at algorithms. And networks and stuff are the norm. This is back in the mid-60s. And of course, computers were, it was personal computing beside the terminal at home. So but we're still teaching programming as if it's just running algorithms, to get results. How many programming classes teach you building hardware these days and having, work hands-on?
That's actually a separate curriculum. I think usually it falls under electric engineering.
Yeah, but that's where, that's why it was good that it was in the EE department that took it. But the problem is that disembodied software is a problem. This is also why people got screwed up in linguistics. Like I also studied the hardware of the brain. That's why I took psycholinguistics to understand. So all these other influences beyond programming, I think, played a big role. Make it closer. I should put up the Zoom camera, but USB is such a pain these days. I won't. One thing I learned is no last minute change to the hardware or software.
Yeah. I think also that kind of it's a good bridge to the connectivity at home, because I think I learned hardware somewhat by like experimenting with devices like analog devices plugged into Arduino or Raspberry Pi that get like the temperature or like humidity, or even light value.
No, and that today is a chance to do this. I'm going to mention like this in front of the camera. So this is a computer with a few megabytes, Wi-Fi, Bluetooth, and hardware controllers and sensors. So I hope a lot more kids get exposed to building stuff these days.
Well, I think though in a lot of cases that a lot of devices come with pre-built libraries. And so usually all they'll do is just import the library and then make the appropriate function call.
No, I use libraries when I can, but the problem is I'm able to go beyond that. That's the hard thing to explain to people. When you're doing things, they're worried about, how to get out of the driveway. And you're at the vacation site worrying about the problems of finding parking. That's a bad analogy, I don't know. But, it's hard for people to appreciate next problems than the one they see. So each of these is a good stage, but then you take it to the next level. So you can sense the temperature, but now what do you do with that? Right now I don't do much, but if I wanted to, I could do this. Oops. Here's the camera. Okay, so all these interesting devices. People could have come here and I could have scared you all with the stuff here.
Okay, Bob, I think you can start anytime you'd like to.
Okay, so the screen is up there. I guess people, if they want to see it full screen, can, or you read a little type. It's up to you. I still don't have to do anything special, right? It's up to the viewer how they want to look at it.
Yes.
Okay. Yeah.
The YouTube is actually showing the slides.
Okay, that's fine. Okay, and I guess I want this to be interactive. It's not going to be that polished. But start out by, okay, next time I guess I got to click the arrow. Click the arrow. There it is. So I've spoken to this group before, and I mentioned history going back to X10. And the last time I spoke, I did show all the wiring in the basement. That's still there. But the code has sort of gotten old. I first started programming this in the mid 90s. So, after 25 years or so, I feel the code's getting a little aged. And I continue to fully understand it anymore. And it also needs to move beyond the X10 legacy. And I was already starting to do some things like in JSON messaging, but speaking, of course, C# and everything, it was getting complicated to support all the different devices. And I also was getting annoyed with IIS, which is Internet Information Server on Microsoft, which again was nice when it first came out, but became a pain. So in August, I decided, why don't I do a rewrite so I could understand the code? I expected it would take a few months before I converted over, but it was actually within a week or two, it was already working better than the old code, because I so shifted it that the central engine was not as critical as it was. And it allowed me then to integrate all the pieces. And TypeScript is actually a great language for this. And for in a Python world, I would say Python, but I'm partial to TypeScript. Now, TypeScript is JavaScript with annotation, which saves me from myself. It's a pain otherwise. And it allows me to basically use pieces of code and multiple things as libraries without having to have really formal libraries. But I built a lot of other tools. My knowledge is all in the tools. So if I need to figure out how to do something, I have to look at the code to understand it. This gets to the question of my coding style is the code itself should be the comments. And I should be able to pick it up 25 years later and figure it out from local context. Again, as an aside, that was the thing for assembly language. I probably in assembly language, some people leave things in registers, of course, 15 pages. And you make a change. Oh, this register looks free. Nobody's using it. Little did you know it's lurking there. So I did learn to be paranoid. And the big changes included, as I said, learning to do certificates. If you're interested, I can tell you more about the tools I built for that. I've learned how to write web servers from scratch, mainly using Express. And some of this stuff I could learn doing my own website. And the really invaluable help in the last few months has been ChatGPT, which has helped me discover all sorts of obscure libraries which I didn't know existed. But back to design point of connectivity. So this slide should scare, I was going to say women and little children, not to be sexist, people, little children. Oh, it moves automatically. So this is the way it sort of it works. In other words, I can focus on just these two devices and the complexity disappears. This is the key point, is you tame complexity by being focused on just the task at hand and everything else disappears. That's the secret of how the internet works. You just look at the endpoints. You don't worry about all the crap between. It disappears and is irrelevant. The other thing is, it's auto advance. I know. Okay. You see, where's my pointer? This thing here, if I can get the highlighter. Highlighter. So how many of you know about the ESP32? But before the slide goes away, the relationships are defined by these numbers. So that's all. It's like basically the IP address. Okay, the slide's moving. This is the reason it's an auto is I took the slide from another deck, and I think it had a life of its own. So I'm going to go back and see if it's going to let me go back. No, here. Okay. So, as I said, the relationship is defined by identifiers, not wires, and that's the big thing. Shift an emphasis to that. And the ESP32 is a $2 chip with Wi-Fi and Bluetooth, and it's currently inside all these devices. So these devices each have a web server, full HTTPS, and all these protocols. So that's the great simplification, the framing. And the point, as I got ahead of itself, is that these relationships work across the entire world. So anything in my house does not stay in my house, to misquote the Las Vegas thing. I'm doing a design here that's meant to scale globally and support applications. So often I use the application of the connected pill bottle, which does not exist now because that crap in the middle called the telecommunications industry is insisting on getting, preventing us from communicating for no reason other than collecting a fee. But the important point is it's those abstract relationships that are what we're trying to preserve, and that are the center of things. It's not command and control, it's the relationships. So, stepping back, the key thing is I learned by doing. And the system is live. So if it's not set up right, my lights are not going to work. So I've got to design a system that's resilient. And even while I'm debugging, it has to always be working. So that it might seem like a hard constraint, but it's really what forces me to be honest and understand things. And it keeps the complexity bounded. And it turns out it's not a bad constraint because bugs show up. The real problem is that the system is so resilient, major aspects of it can fail and I don't even know it. It's hard to find a bug you don't know exists until enough other things fail that it shows up. So it has to, again, work unattended for months at a time. The key components of that are resilience. Means if something doesn't work, you handle it. You don't just say, okay, I crashed. No, that's not an excuse. It's got to continue working. The other thing is idempotence. Now, how many of you, there are no hands to be raised, know what idempotence is? They teach, Chris, do they teach you about that in class? Did Randall say something? Let me get rid of the microphone things, which for some reason obscuring whatever. Was there a hand up?
If you just want some feedback, yeah, I know idempotence as a mathematical concept, and so I think I know what you mean by it here.
Okay, I'm looking at the chat, which is going to be tiny. I'm not necessarily going to be reading the chat, but in programming, it means I can send the same command again and again. It'll give the same results. So that's a key part of resilience.
Sort of like multiplying by 1.
Well, yes, or sending a turn on command if you send it on again. You don't do toggles. You do a turn on because, so you send it a few extra times. If Wi-Fi loses a few packets, so what? You send it again and keep pounding it. So those are things that are key to sort of be able to get all these parts to work together. I also try to avoid single points of dependency, and that's a tough one. I'll get to that later. There are also but whenever possible, there are multiple paths. So I can reach a device by direct IP message, sometimes by going through Habitat or Home Assistant. I don't know if you're familiar with those. So Habitat is a box, that was based on the original SmartThings from Samsung, which they spent $200 million on. People got rich, and basically Samsung failed. And Home Assistant, but these enabled me to embrace a lot of devices. And that's one of the big changes from sort of the Intel X10 world. I now have many devices. And I've got shims when I need to in addition to those. And I just started using MQTT, even though I'm afraid of depending on MQTT broker, which is running on the machine back there. Oh, it's still running. Good. If you see little lights flashing, that's the MQTT status I wrote. So one other thing I won't get into is how do you model these devices? One of the bugs in my early system was I was mainly focused on the concept of turning lights on and off and things like that. One of the things I learned about from the SmartThings is to treat each capability as sort of a different virtual device. So you can have the black and white face of the bulb, which controls the power. There's another one, which is the color face of the bulb. So all these devices have interfaces, which is an idea I was familiar with, but hadn't implemented. It was actually part of what was supposed to be UPnP, not the terrible thing they adopted. So let's see. Just clicking ahead. So the whole design is about cooperating elements. So there is the main engine, which is still there, which has databases, and basically provides here the status of all the devices and acts as a switching center. And my goal is to reduce the reliance on that. Right now, for example, it mediates all MQTT messages. But I now know how to listen for MQTT messages in the web browser so that devices can now speak to MQTT directly, listen for changes. And I discovered only about 10 messages per second, which is not too bad. but I still have to figure out all the scaling issues of things. But one thing that writing the web app that I think I've shown this in the past. Let's see. If you look at the thing, you won't see it. I won't bother with that. Is that it was forced to use HTTPS, which is a mixed blessing because HTTPS is more secure, but it also creates a lot of problems, which is a discussion in its own right if people want. It also acts as a rule interpreter, which we'll see later, and it runs on my desktop. So I actually implemented the control panel, which I normally put up in a slide, as a web app or progressive web app. So the term progressive web apps is a lousy term, but for me, what it means, well, the positive is an app that can run desktop or anywhere, so I can actually run control on anything. But the main reason I use it is that in theory, let me hang up on this. Spam call from Shenzhen. Oops, I thought I hung up. Okay. Okay. So is that the web app should be able to run even if my main engine is down. So the way the web app works, whenever possible, it sends commands directly to the devices. So it doesn't depend on my desktop PC. For devices that do not support HTTPS, whether they support HTTP or UDP, I send messages through Shim Machines, which is running on a couple of Pis and PCs, so it can find one that will relay the message. So this way, it'll work even if my desktop is down. The only problem is right now, the thing I haven't debugged, is if the web app is not already running, it still depends on the main machine to get started, and I haven't had a chance to debug that yet. But again, the goal is to be fully distributed so that the house works even if my desktop is down, the office is down. After a power cycle thing, we've had some last week, everything comes back. I'm lying. The power cycle caused problems, but we won't go into all those right now. So these elements include bridges. As I said, I'm using Hubitat, which is sold as a box. Home Assistant is sold. You can buy a box or you can put it on your own Pi. As a whole group of community around Home Assistant. So how many are familiar with Home Assistant? Okay. Home Assistant you should look up. I put it off to the side, but my son, who I infected with this, actually got up to speed on it. And it's really very good to have corrupted my son so that he can help out to figure these things out for me. But Home Assistant, I think, is the most resilient, shim, but I haven't fully figured it out yet. But the main thing is it makes a lot of these MQTT signaling. And if I did write my own direct drivers, there's a good chance some of the Home Assistant world has written one.
You muted, Bob.
Okay, good. I got rid of the pop-up menu showing me what mic to use. Can you hear me now? Can I be heard?
Yes.
Yes.
Yeah, we can hear you now.
Okay. Now we have to pay Verizon. Okay, so I'm excited about the growth of web devices with the web server, and thanks to ESP32. Not all of them web servers, like the WizBulbs are still doing their own UDP protocol and everything, but I'm migrating to three main devices. There's Shelly. You go to Shelly.cloud. It's a Bulgarian company, which is the one that I think is the lead on this, making devices like this. This is a new generation. I'll get more to that later. How many are familiar with Tesmoda? Anybody with Tesmoda? So Tesmoda is this guy who basically has an open source support for ESP32s, and you can buy bulbs and other devices pre-flashed with Tesmoda. There's also ESP Home, which is another platform from the home assistant community. So there's a company called Kaufman, for example, that's selling bulbs with ESP Home. You can flash with Desmoda, but I decided I'm going to also support ESP Home. So those I can go more directly to, but there's still the problem of supporting certificates in these devices, which are pain. Now the devices which are UDP based, like LifeFix, sorry, that was not meant to be ESP Home. It was meant to say, let's see if I can fix this on the fly. Where's the slideshow? Before we forget, there it is. That's cooperating elements. Okay, so we're back. And Govee is a new Chinese company. The nice thing about the upstart companies, they're more open to implementing LAN protocols. Govee started out with the cloud protocol, switched to LAN. There's also UPnP, which is Yeelight. I'll skip my negative thoughts on Yeelight, but on UPnP. But Yeelight is trying, and they're sold by Xiaomi. And there are others. In case. So the main point, typos. Why did they catch these typos? So embarrassing. This is the audience I'm willing to be embarrassed in front of. Progress. Okay. So let's pretend there's never the typo. So this is still a work in progress. It's still mainly turn lights on and off, lights and levels, because turns out all these fancy effects you don't really need. They're good for showing off to your friends. On Halloween, I could turn the bulbs orange. But in those cases, my wife doesn't want to do it herself. So I can use the many different apps, because each family has its own app, its own silo. So yes, I want to make it better. I want to color temperature better, but I can defer those or rely on things like Home Assistant. I do have an API, so I can write scripting programs. I want to control things, but it turns out there are remarkably few scripts I need. Maybe to keep the porch lights on, maybe to turn the lights off at night if there's still kids here in the middle of the night. But there's not, scripting and automation don't scale, because I'm not in a Stepford house where everything's repeated day after day in lockstep. So that's why camera stuff, I could get them to Home Assistant. Home Assistant even lets you build a web page. But I want to focus more on understanding and sort of make the mundane things work. So now, okay, I'm peeking ahead on where we're going with this. So when I say things don't stay in the house, this is we're learning a world where you can put a little software everywhere, where you benefit by everything is packets or bits. So if you look at AI Chat GPT, that works because the meaning is not intrinsic. Everything is reduced to bits. It doesn't matter what they are. So it can find patterns. And that's what enables these devices to maintain the relationship between the endpoints without worrying about what's in the middle. Because once you've normalized it to packets, the middle is just sort of a generic transport. And the meaning, I give a separate talk on voice ORP, the meaning doesn't exist in the middle. It's just carrying packets. And that's why these ideas scale. Yes, the protocols don't work transparently, but shims and everything I can put in, because the IP protocols and apps don't depend on maintaining the timing. That's the problem with approaches like, remember FireWire, what a disaster that was, or Bluetooth? Those have basically timing limits around trip assumptions and everything. And they become brittlely dependent upon this complicated stuff in the middle. Whereas the whole point about IP is I have to discover on the ground what works. So voice over IP is actually a great example, because it only exists because you cannot basically buy priority in the network. In other words, there's no way to buy better treatment for your packets. You can get a fatter pipe, but that's about it. But once you're in the generic shared network and shared environment. So voice over IP only started working because of generic capacity created for the web. And then it just started working by magic. And the same way, the things I'm doing scale will work better and better as the barriers to connectivity fall, and I can just send generic packets anywhere without having to worry about third parties in the middle. That includes firewalls and other crap second guessing what I do. Now, on the side, you see this little thing for the latest Shelly thing, which is why I'm excited about Shelly. Let's see if it's still a pen. This, no, I shut it off. Okay. So, okay, we need to go back one I clicked. Okay. It says highlighter. Good. Okay, so you're able to, it's not full JavaScript, but you're able to write little codes on the devices. The challenge is that you don't want to write just arbitrary code everywhere. You want standard protocols and everything, but you're not limited by predefined interfaces. So you can start to experiment with new APIs. And there will be a lot of harm caused by people getting themselves in trouble doing this. But it's a learning opportunity. And for kids programming, it really means you can take the physical world and turn it into software. So that's sort of the direction we're going in with all this. So let me give you an example of sort of some of this in action. So there, Leviton Lutron, it was supposed to, okay. I set the time and all the things, so we can tell. I'll tell the story. So much for my being too smart for myself. Okay, so when I press the button here on this Leviton, it sends a special proprietary radio message to this interface, a cassette. That goes over the Ethernet to Home Assistant. From Home Assistant, it goes to via MQTT through another Pi machine sitting back. So these are two different machines that goes through over the network. Then my main machine, which is a little nuke box, is listening for the message. And then it sends the messages. Well, what it does is it gets the message inside the MQTT handler. It uses HTTPS within that box to send a message to the main program, which then gets the HTTP message from the MQTT listener, which then goes to the rule engine recursively, and then sends messages out to all the handlers. So any guess on how long that takes from the time you hit that button? Anybody want to guess?
Half a second?
Close. Oh, I've got to turn off this. If I want to click on it, I've got to go shut this off. Okay, click on it. So think of how many steps that goes through. So the thing is, the design has all these elements. So the problem is if the MQTT handler is not down, the cassette might fail. But so this is on one of the walls. I've got these three next to each other. I've got the Lutron, which is nice, but it's a tactical thing. I like the idea of having a physical button I can press. I also have the Tasmota, which is a nice drop-in for an old light switch. If you still have a circuit where you control it locally, that's basically using a Tasmota protocol. You can send messages; it'll tell you the status. And this, okay, so Lutron depends on that whole chain I talked about. Tasmota can send messages directly. It can send HTTP messages directly, or it can send messages to my rules engine, depending on what it is. Now, to get a little geeky, so the way the rules engine works is the simple rule says whenever I turn this, hit this, get this message, this device comes on, turn on these other devices. Now, the interesting thing about that rule is there's no difference between that rule and a scene. So if you look here, you see this image which has ceiling. That's that rule unwound, so the rule can be executed in the device. So the device I can implement arbitrary complex rules in the device itself. So part of sending the message down to the device is not only do I send, okay, this button controls this device, I can send this button controls this family devices, and each of those can have rules. Normally the rule is just transparent. And the way you get this screen here, if you want to see what's inside, is a long press will pop up the screen so that you can see what's behind the button. Now, this UI needs a lot more work, a lot more polishing, but it focused on sort of this basic functionality. And just to give you a sense of what's up here, so this is extended commands. This allows me to go to other rooms through the main menu. This is how many seconds it's been running since the last. Oh, there's only half a day. That's strange. Oh, because no. In any case, an external IP address, which turns out to be strange because that's one of my secondary addresses I can't get here. I don't know why I got that. And then the ceiling controls all these at once, which is what you see here. And each of these, in this case, you can actually see the lower buttons. You can't always see it. There's a weather widget. I can have other videos. So the doorbell can announce. So that's basically what you really interact with. And the key point here is that really focuses on the main engine, all this, but the real center point is that these apps can run independently each device and cooperate. And I think where the future direction there is, so the reason I'm cautious about MQTT is that you need to give the name of an MQTT broker. If that broker goes down, you can't get the message. So I use them as advisory right now. Now, one of the future considerations is resilient MQTT by dynamically changing the name in the HTTP server. But I'm getting ahead of myself. So here's a key slide, is from naming to binding. So when last spoke, I would name a device like K-Sync 3, which means a third device over on the sink side of the kitchen, and put that in the bulb. So that bulb is now K-Sync 3. The problem is it's part of scene, it's part of thing. If I switch bulbs, I got to move the name from the bulb to the bulb. Too much work and too problematic because you get multiple roles. So instead, I keep the native name, which basically, this is really basically the MAC address. But I don't want to depend on the MAC address not changing. So this, that name you see, the cow bulb, whatever, is the intrinsic name of the device. There's actually a feature, by the way, of Instant that had intrinsic names. You couldn't change the ID. So it also has a friendly name, but that's secondary on Home Assistant. The main point is that one of the major changes in database, and this is why it's nice to use a database, is I separated the binding name, or the MAC, the DNS name, from the role name. So I can basically have bulbs, change the role by just rebinding the name. I can make it part of rules, point to it. And I used to think things are family, like it's a Habitat device and all this. And one recent change is, no, this device can now exist in multiple paths and be reached multiple paths. Contrast this Windows. Well, if you have the same printer, but it can be reached over IP or Bluetooth or USB, it's a different printer. Windows has no concept that the printer is the same endpoint. So how many of you remember the days of UUCP? You're old enough, admit it. When address would be A bang, C percent, question mark, whatever.
Worked fine.
What? Just speak.
Worked
Yes.
fine for me.
But the problem is you can say A bang, C bang, go 30 levels, but you don't know that it turns out the two A's are the same. You can't assume that. So the nice thing about having unique identifiers like this, or GUIDs, is that you can now assume those are the same. And and the at name separates the path of how you get there from sort of the name. The problem, though, is the DNS is still in the old things where you would name things casing 3, or you can have only one Joe's.pizza in the entire world, or one house of pizza in the entire world. That doesn't make sense. So you can look at my Forever URLs proposal, which is we need to fix that. We need to remove the semantics for the DNS to give you an option for non-semantic names, which then never have to expire. Now, at the beginning, someone was asking about certificates. Certificates are bound to the accidental character string of the moment. There's a long window. If somebody buys or steals House of Pizza, you still go to House of Pizza, but you'll be going someplace else. By separating out the intrinsic identifiers, the GUIDs, this is what we do in all databases everywhere in the world. That's why you can change your name. You don't lose your Social Security benefits. So what's amazing, this gets back to Chris's comment about learning computer science. Do they teach you about linking identifiers in databases, Chris?
I'm not familiar with that.
Okay, basic idea. So you learn about relational databases?
Yeah, I mean it's at some point. Yeah.
So how do you link tables in relational databases?
Is the join?
Yeah, but when you join, in other words, a key field. What is a key field? The value of the key field. What
Is that the unique identifier?
Well, but it's unique because it has no semantics. It's just a random number. Now, the more recent ideas in databases is the GUID. So you can use simple indexes for local databases. But if you want to have a database that's distributed, where you have data generated in various places, you need a global unique identifier, or GUID. And those are self-chosen big random numbers, and that's a powerful idea. So this is really a core idea in my design, that all these linkages are done by global unique things. So I can take a device anywhere in the world, it'll have the same binding identifier. If I replace it, I change the bindings. So I can have as many levels of indirection depending on what kind of flexibility I want. So I'm going to get to how I handle that. But if you get a chance, you can look at the Forever URLs, which is under my keyword system, rmf.vc. So part of this is I can't write all this myself. I'm not going to reinvent the entire world. I'm going to do a lousy job. I got to admit, like when I discovered the smart things, as much as I thought the rule engine orientation was wrong, they also did some things far better than I did. One thing they did not do was when I wrote code, sometimes I get a 3,000 line Java stack dump. But otherwise, they thought through some of this long after more recently. So the thing is that root or NAT at the edge of your house, some people curse. It's what enables me to experiment and try out ideas and repurpose NAT protocols without having to fight with people outside the house saying, you're doing it wrong. You're not allowed to do that. And the other part of philosophy is local first. So everything can expand to the world, but it starts locally and works locally. And locality is a very important principle here. It means even when the power's out, I can still turn on my lights. Wait, that doesn't make sense. Okay, maybe I can't turn on my lights, but my internet connection goes out, my house still works. Though if I had a backup generator, I would be able to turn on my lights. It must work locally. It doesn't matter if the outside connection works. The irony is my internet connection is more resilient than my power connection because I've got multiple paths. One of the hacks I did was recognize that the DHCP server is a DNS server as far as we're concerned. So that I can, for example, my main machine, if I didn't spoof and shadow addresses locally by putting like my local address in, then if my outside connections failed, I couldn't get to my desktop from the device in the hall. But because I spoof it, so it has a local address, even though it also has a global DNS address through a port forwarding, means local things can work locally. And I can also then put password checking or other credential checking in for external references, but not local references. And a little aside, one thing I realized is that the problem with the MDNS, so I assume some of you are familiar with MDNS, it's sort of the success of NetBIOS allows you to have local names for devices rather than out the DNS. So a device can call itself, foo.local, and you can get to it. The problem is that if you broadcast things don't work. So by registering things in the DHCP server, I then get a persistent name for them. So I basically, I mean, this is in addition to my external zone files. So, and then, there are a lot of bridge and shims to the larger world, from the larger world, like port forwarding things. The other thing I also do is I rely on Ubiquiti to fill in some of the APIs not, available globally. For example, turns out there's no mapping of IP address to a MAC address. So if the IP address, I want to find the MAC address. A lot of these, or the other way around. In any case, those mappings are in the DHCP server, and by using Ubiquiti APIs, I'm able to find those mappings. Eventually, I'm going to implement more native to DHCP server interfaces, so that I can basically. The main point here is the internet was a nice engineering experiment. It was a network of networks. It's still caught up in the idea from the dial-up days of the way we thought about it. The term accessing the internet means it's somewhere, it's a long-distance phone company. And as a matter of fact, in the early days of DSL, it was exactly that. You would sign up for a long-distance phone company and for your internet provider. I see it more as peer connectivity and binding. It transcends the network of network. The internet is not there yet, but it can repurpose protocols to drag it kicking and screaming into the 1990s. So, so the main thing is the current protocols I build on that. I use HTTPS, I use WebSockets, MQTT, the secure version, not secure version. And the big thing is JSON bundles that I can do of everything. So that's, and I mean, you look at also like Shelly and Desmodo, they all accept JSON bundles, whether they come over MQTT, whether they come over HTTP, whether they come over WebSockets, is a very powerful, flexible approach. As I said, I manage my own certificates. I mentioned before this talk that I do it by having a program that basically does an ACME request. Then I update my DNS zone file, and my DNS zone file is managed by a friend of mine who's also actually put a nice thing so dynamic addresses work. I'm not limited by CNAME. And thanks to ChatGPT, I can only tell if you're interested in how, I get to search dynamically when you make a call. I see who you're coming from. Oh, here's what you want to reach. Have I got a certificate for you? And then present the appropriate certificate. But it's still a challenge. These small devices don't make it easy to put certificates in. So I'm still learning how to do it without, breaking the world. So these are all works in progress. But the main thing is, unlike UDP protocols, HTTP, WebSockets, MQTT will work from web apps. And why write a native app when you don't have to? So I'm also telling lies. For example, Wi-Fi is the best thing out there, but it's still a disaster. Often get devices don't connect to Wi-Fi. A lot of devices aren't smart about retrying and things. And partially I'm sensitive because I'm in the middle of a perverse failure mode, which we try to spend more time to fix. And it might have been precipitated by the power outage, but let's put it this way, I'm getting perverse failures. And enough said. Progressive web apps too, I'm still learning. They keep exiting. I suspect when it updates the browser on the phone, it'll exit. I don't know what's happening. It doesn't have enough low-level access. It would be nice if I could do UDP from it. And the HTTPS restriction is a pain, but in this case, it's forced me to learn how to use HTTPS because I don't believe in firewalls. I want everything to work without a firewall. the firewall is one of these crutches that creates vulnerabilities. But for make all this working, there's a lot of tooling I need. Like if you're going to use abstract URLs, you need tools to do it. And I've got a growing to-do list. So the other point is the single points of failure. Wi-Fi is a problem. You depend on access points. Fortunately, multiple access points, but you're still dependent upon them. A single DHCP server, your DNS, all these things, single MQTT server, So all of these things are concerns for making more distributed. And the future direction, as I said,
live streaming is on.
Live streaming is on. I can echo it too. Okay. So speaking of tooling, where we left ourselves off, I make heavy use of tools, and my knowledge is in all these tools. I decided that it's not so much I'm getting older and forgetting things. It's just my buffer overflow, because there's so many different things. Things, if anything, are accelerating the number of different things. So just as people were concerned when writing was invented, that people would not learn how to memorize. And that used to be the main skill. So today I rely on all the pieces of code I've got lying around, strewn all over the place. When I'm about to do something, I look at the code. So it's mostly TypeScript. The reason I like TypeScript is a program is a system with type annotation. I don't believe in strict typing. I'm not going to force myself. It's just like, do you remember the days when you told you weren't supposed to split infinitives because some old biddies from the 19th century thought we were supposed to speak Latin? So the SQL Server, because I use database techniques, this is why I was asking about learning database techniques, meant I can restructure. That's how I changed from using these names directly to making them binding identifiers. JSON bundles should be JSON bundles. I do depend on Ubiquity. I'd like to move beyond from managing on what device are connected, whatever they are. But they're, not exactly what I'm doing with this vision. But the other thing is I can quickly now write programs in TypeScript, and if you want Python, to do things. For example, if I want to swap, it's called swap bulb, but it's more general. Where I say, okay, I've just unscrewed this bulb from this socket. The location is called ksync3, so that's the binding name. But now move that binding over to this other bulb I just put in there. So that becomes a simple command I can type in, and if I wanted to, I can put in my web interface. Thanks to MQTT, if I put a new device on, it'll see a message for the device, go to the device, ask what device you are, figure it out, add it to the database appropriately, automatically. And then I have another program which goes through, finds all the devices, and generates, I just have these little labels. Oh, printer just printed out a few, got connected despite USB. So these labels, which I put on every device, this is part of my paranoia. If it weren't for this, how would I know what device this is? By the way, it also does help to have a double E degree, even if it's a fake double E degree. So you learn how to wire these things and electrocute yourself. Shutting power off is something for children to do. So I should put in a bad word for Matter. How many of you have heard of Matter? Anybody? So Matter is the future of home control, home automation, circa the Jetsons. Again, it's another example of hardware people not understanding what they're doing. The reason I'm mentioning it all is, it's one of these things, just like the terrible idea of 5G, which is a tragedy in its own right. It's done by hardware people who do not understand fundamental concepts. And then it's perimeter security. It has bit layouts rather than JSON bundles. And you can't do, here's one example from CS, a Matter faucet until the committee figures out what the interface is. These are ideas that we abandoned 30, 40 years ago. They reappear periodically in CBus, they appear in Firewire, and things like that. And no surprise, it's done by Silicon Labs, which is doing Zigbee and Z-Wave. So I just want to put that to bed. Any case, this is a partial to-do list of things I've got to do. I would ask for help, but it'd probably take more time explaining it than things. So I think this is about time to see if anybody's still awake. Questions, answers.
I haven't fallen asleep.
I'm still awake.
Okay. And for those in the Boston area, if you want to visit, you know, this is real life stuff working in action. And it's the way I learned. For example, understand. I mean, the real value here is what I've learned over the years. One of the earliest lessons was the need for relationship identifiers. No Internet protocol allowed me, this in the 90s, to connect a light switch to a light bulb. There's the IP address ephemeral, the DNS you don't own, all these problems. So this is learning by doing. And the real lesson has been the shift from when I first thought about, wow, I can write a program to turn lights on, to the idea that this peer connectivity, bulbs can send messages to each other, switches can send messages to each other. And the challenge now is to understand and tame that. Because, you know, there's when you restrict things, you simplify it, but you also build in a lot of attitude. When you don't have any restrictions, you're all over the place. There's no commonality. So I'm trying to find the path of the middle. So people I can normalize devices so that I have my own standard internal interface, so I can control an ESP Home device, a Wiz device, and Philips, all of my own software. And that's similar to what Home Assistant did. So I can leverage their normalization. Now, the normalization doesn't mean you get to all the functions, but it increases the span. But if you start to program things totally idiosyncratically, you don't get that leverage. So it's sort of like the open source world. The projects that work have a dictator that, you know, coalesces things, or they're built around existing models. So you have an example. And at some point, they decide, okay, the idea is dead. You switch on and abandon it. You don't need to make it work forever. So I think there's going to be edge of people who will use all the flexibility in these devices to track new ideas. But over time, common ideas like JSON bundles will emerge. There'll be a standard format. But unlike the days when you would build a whole new industry from CDs to DVDs, quite a whole new industry, we can still use the common packet infrastructure, and that's the really powerful idea. So we have these common levels to build on, just like I use Internet protocols. So that's enough of a rant for now. It's 8 o'clock. So those of you past your bedtime, what questions do you have? Anybody? I'm going to bring this down. I'm going to shut off the screen sharing because there's nothing to see. Just move on, folks. So stop sharing. Okay. Now I'm able to look ahead and see people.
That looks good.
I should do the slideshow too.
So I guess my first question is, I guess, why? In instances where there were other existing solutions to accomplish the same problems, you know, did you feel need to understand it and implement it yourself?
Okay, let's take an existing solution. You want to turn on a light. You could run a wire through the walls, fish through the walls, take it to a switch, and then whenever you want to shut the light off, you slam through the wire, you cut it. You have a little mechanical thing that does it for you. I mean, you could do that. But that doesn't accomplish the idea of you controlling the light. It's just you want by sending a message, you get flexibility.
Yeah, I guess I mean existing IoT solutions that already.
Well, first word IoT is terrible, but name a solution.
Well, I guess say like a Wemo.
Yeah, but all of those.
Yeah.
The problem with Wemo and all those, especially the Toya-based ones, is first the terrible architects done by incompetence. Let's put that out to the side for the moment. The design, they all tend to be dependent upon a server someplace far away through a monetization engine closed proprietary APIs. They don't play well with each other at all. So you can't mix and match. You're stuck within their silo. And if they don't do it, sorry, it doesn't exist. You want to do a new device? Sorry, it doesn't exist. But you're stuck back 30 years ago in the Jetsons design point. Now, Wemo, which I think that's the Belk one, right?
Yeah.
They did experiment with open interface, UPnP, but there were also security concerns and everything. So so they had a chance to be open. I tried it, but they never really got it to work well enough for me to use. And now they're owned by Foxconn. I don't expect much. But
Yeah.
you take a look at some of the others, and they're totally closed. And let's look at so you look at Philips. So their Philips Hue line, terrible name for a product, is Zigbee based. So they have a pretty open API to their bridges, and I could program to that, but depending on Zigbee and all the other crap. And lately, but I won't go into some of the other things they've done for marketing. They also have the Wiz line, which is IP based, but it's UDP, proprietary protocol, undocumented. Fortunately, it's a simple protocol, so people reverse engineered it. Thank you, Wireshark, and all the people who did it. So I wrote my own program to their UDP interface. But for example, if their stuff doesn't get an IP address, it seems to give up and never get it, as opposed to other things like Tasmode and stuff, which seem to keep retrying. So I will use things that are out there, but I need a bridge to them in order to make them part of the whole. So the short answer is the things I want don't exist. Even Alexa in the kitchen. So Alexa, I've used a little, and I'd like to use it more. And if somebody knows how to write Alexa apps to do what I need, I'd appreciate it. It's just one more task to master. And specifically, let's say, what devices define kitchen? Alexa is not designed, does not scale to 100 devices, 200 devices, 300 devices. And when you try to rebind, you replace a bulb, you don't have to tell Alexa, you have to tell Google Assistant what the thing is. Now I could try to make go via binding identifier, Habitat has some of it, but there's no simple, here's a way to connect and define what it is. So part of the things I want to do is build the bridges to those, but they're still bridges. The goal is, okay, what are the big ideas that basically make me think in terms of binding of things? And the real problem here is the economics. The economics of devices is broken. So, about when the TV company's ratting you out, you buy a fancy TV and it'll report back to somebody in Shenzhen what you're watching. Okay. Now, some of them are caught doing it, some of them they're not down. But the reason they do this is you can't make any money selling this stuff. It's pure commodity. And the same light bulbs. So if Wiz is going to send me an IP light bulb, how do they make their bulb more valuable than generic light bulbs, generic smart bulbs, a Tasmode bulb? Well, that's the problem. They keep trying to do it. For a while, they're only selling via Home Depot, so they control the channel. It's futile because they're selling hardware with the values in software, but they can't get the benefit of that value if you can escape their silo. So that's a fundamental problem, which is why we need different market structure. This is why I'm so interested in Shelly, that they have kept it open and including making more open. They'll even encourage you, so you want to run Tasmode on this? Flash it. They'll even tell you how. So I like it that they're able to do that. And that seems, unfortunately, more the exception than the rule. I don't want to spend my time fighting Sonoff or Toya about how to reprogram the devices when they're actively fighting to prevent me from doing it. But what I do miss is like the choice of form factors from Philips, for example. That's why I still have some Philips bulb, because it's the only bulbs I can get those form factors. But companies like Govee might be amateurish, but they're creating more interesting devices. I should encourage them to do others. Devices. They're very inexpensive and very responsive. So when I complain about no LAN protocol, they said, we're actually doing that. And now it doesn't mean the whole product line is doing this, but part of the product line is very interested. because there is somewhat of a hacker mindset. Unfortunately, some of the companies like Wise, WYZE, don't get open, and they're still trying to do cheap, nice stuff, but they don't. You hit a wall when you try to make creative use of it. Did I answer your question?
Yeah. I was also asking, can you plan to expand to like thermostats or fire alarms?
Okay. Well, thermostat I can. Ecobee is reachable via Home Assistant. They've got their own API. It's just there. I'm willing to use Home Assistant or the Ecobee native interface to go through the app. In other words, I'm not trying to automate things. I'm trying to sort of address, functionality issues. It turns out Home Assistant supports cameras, so I want to figure out how to use. I could create a complete Home Assistant page. If you look at Home Assistant, you can create your own screens like I do, just in Home Assistant, but it's dependent upon the Home Assistant engine. I want to use some of this stuff. So one of the things I was looking forward to with the Nest doorbell, hello, was listening to messages for turning on a light. Especially a lot of the engineering was done locally. I was encouraged. But since then, Google has cut back on the API promises. Their interfaces keep changing. The security. Now, I do understand that these large sites have hyper security problems and they're worried. But the price it means I can't do things. So if you saw that picture at the beginning where all these relays and wires and stuff, one of the primary reasons for that was to take the Nest doorbell signal and turn it back into a binary switch, which I can then convert and send a message. So the answer is yes. I would love to use all those. Love to use APIs, interface, don't want to reinvent. Unfortunately, it's not really an option. Now, again, I will use as much as I can from Home Assistant, Habitat, and others, so I don't have to reinvent everything. But there are still issues. Other questions? I'm trying to recognize Bill R's background. Where is that?
That is Commonwealth Pier 5, formerly known as World Trade Center Boston Head House, viewed
Yes.
over the viaduct from the Seaport Hotel upper entrance.
Okay, so this is a recent picture.
Early this century.
Oh, well, this century. Okay. Oh, so this is. I remember before the hotel and all this. When you were able to drive all the way over. Yes.
Yeah.
Okay,
Well,
I'm just curious.
if you are working a function at the head house, you still are able to. It just takes a little special permission.
But does it go? It doesn't go all the way across, so it still doesn't. I forget.
Oh yeah. I've seen satellite trucks parked at the top
All
of
the way.
on the head house balcony.
They go all to the conference center, the Boston, whatever it's conference center.
Yeah, and taxis can. Well,
Okay.
they're completely rebuilding the conference center in the head house currently, so nothing's accessible at the moment. But
Okay. Well,
until quite recently, taxis would come pick you up at the conference center turnaround.
yeah. No, I remember. Yes, some of that. Yes. In any case, other questions? Do you want a tour here or anything? Could give you a tour. It's not worth it. But it is a pain. I would actually like to be doing more writing and stuff, but there is one feature it has for me. My way I handle ADHD is I use programming to relax. So the to-do list gives me a chance to relax. But the problem I have is I don't want to tackle any projects that can leave things broken. So I'm limited to things that have to be working by the end of the day. But that's another major constraint. Great. Somebody looked up Gracos. Yes. There is an advantage, by the way, in studying computers in the EE department. But even better, when you did in the 60s, and you knew more than your professors about it.
Of course, John could get better glasses.
Say that again?
Jabber can get better glasses to read the to-do list.
Oh, well, actually, there aren't enough pixels in what I did for you to see the actual to-do list.
Mhm.
But
Glasses driving.
what?
It used to be I'd wear glasses all the time. In the past, like 5 or 10 years, maybe. I still need the glasses for driving, but I can't really see anything up close when I'm wearing the glasses.
Oh, you see, I had a different problem. I discovered I was giving a talk in Sydney, and my glasses broke. My frame broke, and I was going to like reading glasses as a temporary thing. Discovered, no, I've got astigmatism. I can't just get glasses on the fly. Fortunately, I found some cheap frames. But yeah, so it's not just about magnification. So anybody else playing with this kind of stuff?
Yeah, I had the let's go back. Like I use like the past 3 houses I've lived in. I've set outdoor lights using smart bulbs, and those bulbs come in with a built-in app that seemingly goes online somewhere to look at a farmer's almanac, and it knows what time sunset and sunrise is throughout the year.
Yeah, that's easy to get. There's a lot of APIs for that.
Mm-hmm. Yeah, and then the smart thermostats. Like I used to live in Newburyport and have one of those old oil furnaces and a drafty house, and the algorithms help to make the heating more efficient and save money. So I found Nest thermostats to be a good investment.
Yeah, my HVAC guy was in recently. He said he's been removing a lot of nests because unless you're in such a situation, it's too smart for people. But one other thing, important aspect of this is, how many of you are living in houses versus apartments?
Yeah, my condo.
I live in a condo.
Yeah,
Yeah,
well,
I'm in a
condo,
townhouse now.
yeah. The nice thing, how many of you can cut holes in walls whenever you want to?
As long as I don't cut into the neighbor's wall.
Well,
Okay, but
owning your own home doesn't necessarily make that totally easy, because I've got horsehair plaster.
oh, it's not totally easy, and it's more than rewiring. I'll put it this way: the reason I call an electrician is they're better cutting holes in walls than I am. I can do the wiring, but I need them to cut the holes.
Yeah, I think the first thing I did after I got the place where I live now is was have an electrician come and wire and run the Ethernet. The first floor is usually pretty easy, because you can get to the basement. But the second floor is usually the trickier one.
Well, that's why I've got a lot of wireless. You have Ethernet in a lot of places, but there's a lot of wireless. But I did this in 1990. At 93, I future-proofed my house with the most advanced Ethernet wiring I can get. Cat 3.
Yeah. Yeah, I have my condo here. We moved in August. The only major hole I had to make in the wall is coax, because I wanted to, for Comcast. So I wanted to.
No, Comcast doesn't need coax anymore.
What?
With Verizon, I use their box of Mocha Bridge, so everything's over IP. The new Comcast set-top boxes are generic IP boxes now.
Yeah, the Comcast boxes are all wireless or Wi-Fi, but I wanted this computer to be wired for performance.
Yeah, but why did you wire it to Ethernet?
Because all I had to do was drill a hole through the wall, and I had a coax in the next.
Well, that's no. If you have the coax, I can see we're using. I even have a 2.5 gigabit Mocha bridge.
Yeah,
Well,
it's
for
a Mocha.
the most part, if it is, I wouldn't put coax. I'm saying I wouldn't have put coax in unless it was years ago. I mean, years ago, yes, you had to do it.
Yeah.
But these
Well,
days,
Like upstairs where I am right now, we've got two coax. We've got two coax connections. One in a bedroom, and another in a like where the TV is. You know, neither of those are used. So what we did is drilled across and just. We didn't even drill to the other wall. We had the coax between the walls, so we just pulled the coax here.
one
Because-
use of coax, by the way, is to pull the Ethernet cable through the wall.
Yeah, it's just was convenient.
Now you can glue it to the end. And you pull the Ethernet through with the coax, where the coax goes.
You're talking about 2 inches.
But what we're someplace, I can never find things when I need them. I did find a pair of 2.5 gigabit Mocha boxes.
Yeah.
So it's not terrible to use coax, but you wouldn't want to do it new.
Yeah, because everything else in the house is Wi-Fi. So
Yeah.
all the TVs.
I find I've got between 275 and 300 endpoints, depending on what I'm trying out.
Yeah.
And the vast majority are Wi-Fi, which is why I can't get a consumer box. Turns out if you get consumer routers, they all have a 256 limit. And think about it, there's a time when that seemed big.
Yeah.
So that's why I see a 172.20 address here. So other questions? So who is doing a lot of home control stuff now? Which of you?
Yeah,
Nobody?
I think right now, like I said, I'm doing the smart bulbs, the Nest, the fire detectors.
Yeah, I do have the Nest fire detectors.
Yeah.
Okay.
Well, it's especially good, like, because we have pets, and if we're not at home, it's good to know when the fire alarm went off.
Yeah, it's also multi-story. The one problem I had with the Nest, I heard it going off. There was a test thing. Then I realized it wasn't the Nest; it was a bird with the same kind of sound.
Okay.
Chirp, chirp.
Now I had in a previous condo I did have the upstairs using essentially remote lights. I forget what protocol I was using, and the can that we put the lights in was actually wired and not the light bulbs.
Wait, the
But I was
cable-
able to turn them on and off remotely.
But it uses what, an older control system relays or something?
Yeah, that was several years ago.
Yeah.
I
No,
just
I mean-
forget
yeah.
the protocol I was using.
Back when X10 was the most advanced.
And it's amazing how long X10 lasted because it didn't try to second guess what you were doing.
I know that's kind of tangentially related, but when I had the free time, I was really into trying to parse digital data over radio. Just kind of like scanning the frequency spectrum for digital communication, and then trying to decode it.
Yes.
using like a SDR, like a software defined radio device. It's definitely a lot of fun. Yeah.
And you too can publish your secrets.
Well, there's nothing really too interesting. I think the only new development, like there used to be police bands
Police band's gone now.
Well, they're using a digital, an encrypted digital voice solution, where it's sending a digital signal over like a narrow FM.
Yeah, more and more departments are
Mhm.
going digital encrypted. So
I mean, it's amazing how long it took. But
track of what the cops are screwing up.
Yeah, I mean, there's some open source solutions with some common encryption algorithms that can decode some of them in real time. But I think any ones that use more advanced ones are harder to crack.
What they should really be using is a public packet infrastructure, but we don't have that yet. But that's a whole conversation in its own right. But, well, the cop car, I mean, that's a whole nother discussion. It's sort of, I think, well, called super glue technology, where you get all these disparate things, you glue them all together in the car. They don't all work together, but at least you have a big van just to hold all the different unconnected technology. You know, I mean, part of the problem is how many people understand how this stuff works underneath. It's all magic. So any other questions or topics or curiosities? Stories from when I was a kid. Discovering you could hook up a phone to a radio and listen to the Long John Nebel, then James Randi and Gene Shepard under the blankets in the middle of the night when they didn't know it.
Well, actually, I'm curious about, like, you know, how do you go about like writing an assembler? Like, do you just wake up one day and like, I'm going to write an assembler?
No. No. Remember, there was no choice when I was a kid in many cases.
Did you have, like, before that, did you actually have to look at the actual machine code and figure out, like, okay, here's the letter A.
No.
Here's the number 4.
No, luckily we had assembly programs to take care of that housekeeping. I mean, I was actually, when I first learned to program, fortunately, I was taking a class at Hunter College, and they taught us machine language of the 1620 as well as Fortran with a Mary Delciani teacher. I remember her name. But they only let me write one program in Fortran. But the good thing is I was taught how the machine worked underneath. Then 1620 an instruction where you give an opcode and 1 or 2 operands and a flag and all that, and it made a lot of sense to me. To this day, I can type 160000 to clear the 1620 memory. And I wasn't sure about it, so I did check to find an article about it, confirmed it. Unfortunately, then I looked at the author article, it was me, which wasn't a very good way to find confirmation. But later on, the IBM 794. I didn't write machine code on it, but I did look at the machine code to read the principles of operation. And there's some wonderful instructions. Like, how many of you know Lisp? Yeah.
I used to I did a little bit in Lisp, not much.
Do you know where the terms
A long time ago.
Do you know where the terms car and critter come from?
It's been around longer than any of us.
Okay, it stands for Contents of Address Register and Contents of Decrement Register,
Right.
based on the IBM 7090 or 794 instruction set.
Okay.
So it's that kind of sort of arcane knowledge. But you mentioned 7044 being a 32K machine. That was a 15-bit address, so 36-bit address can 6-bit opcode and 2 15-bit fields, or 3-bit opcode, or the modifiers. So so those kind of things I just learned. It's enough of a nerd that I would enjoy going to the IBM. IBM gave away free manuals in the old days. You go to the IBM offices on Madison Avenue, 7th Street, raid the manual libraries.
I
But
used to have a stack of them.
I had to learn
Was that in Manhattan or was that in Boston?
Manhattan.
Manhattan, okay.
So, but my first job, but working I'm trying to remember the first, so when I got the job at White Weld in 1966, everything was in assembler language for the operating system. Fortran would have been a very suitable language anyway. So we just wrote an assembler. It just seemed natural. I mean, that's the thing about writing an assembler. It might be tedious, but it seemed natural. I mean, when you write a program, you just have a few variables. You have any number of variables, but when you did an operation instead of A plus B, you would say, take A, put in the register, add B to the register, save it. So you just write out the steps. So there's nothing. It's not really that arcane. It's
Yeah.
more tedious. And I'd be I remember one of the programmers who would write assembly language and put instruction like jump 3 steps, 5 instructions ahead in a block of code. I was not that dumb. Or I gave the example of the branch instruction in 360, which allowed you to patch the bits instead of having separate flag. And some people would do practice like that. So at least I had an early sense of aesthetics in programming. So if you're disciplined, you can actually make assembly quite visible. So when I wrote VisiCalc, there were no go-tos in the assembly language. It's written in assembly language because how else can you get this fit in 6502, which is an 8-bit machine, all this. But I had a challenge of how to write code I can understand and debug in assembler. So it was all basically no go-tos. Go-tos themselves are not even for mathematical reasons, but it becomes spaghetti code. You cannot trace the dynamic state by looking at the static state. Now, where I had to, but if it was cheap, so I had the call return instruction, which said this is a call followed by return, which is really a jump, but you knew that it would return to the caller. So when you're writing assembly, the key thing is good practices. Like I said, in the example I gave earlier, don't leave something in a register or a page without warning people. So it's actually not that hard to do, just tedious. But what was strange was in the early days. So I had multiple jobs. There was the Multics group at MIT, which is high-level language for the beginning, PL1 and everything, much better than IBM's PL1. In my outside job, I'd be programming the IBM 360 in assembler, and then I switched to using IBM lousy PL1 to write debuggers and tools. So I would go to high-level languages. So one story was, in the old days with the punch cards, when you made a change, you would submit an update deck, but you wouldn't read through the whole program. You'd submit an update deck, which would run upon and generate the new deck. So you had a history of the changes. Well, you're online with the terminal. You're not going to type an update deck. Yet the old line programs that did. So I wrote programs to generate the update decks dynamically. So I wrote tools to sort of tame assembly language. So it's the same way, I say, don't write in C++, that's cruel and inhuman punishment. Sugar assembly language. I can do it, but only if I have to. And there are less and less instances I have to. And it turns out programming in like JavaScript has advantages over statically compiled code because you're compiling on the fly, so you don't have to worry about all the edge cases. The edge cases happen, program will adjust, but you don't get the performance hit by having to check for them every time. So a lot of the concepts of programming have also changed.
Yeah. Well, I mean, what I'm finding now, especially with cloud computing costs skyrocketing, is that a lot of people are looking for those to make those efficiencies where, if you shave a few cycles off or gain a few milliseconds in an application where you're concurrently doing, possibly hundreds of thousands of transactions.
Trillions.
Yeah. Okay. Yeah. But at least I'm finding a culture that is going back to look to make those efficiencies, and then kind of looking away from parsed languages where there's the simplicities cause a performance penalty.
Well, yeah, but again, you're also getting some people who just like to twiddle and put their hands into the mud because it feels good. I understand why we have language like Rust and Go, and people experiment with how do we do this low-level stuff. So if I had to do it, it's CUDA programming and things like that, massive parallel C. So I still have those, vestigial skills. But for what I do, turns out, for example, the cooperative threading of JavaScript is a major advantage for me over the kind of threading I get in like C#.
Yeah.
We have to worry about all these locks, and there's too much freedom. So there's a with the grain aspect too. And the trick for a lot of things, the twiddling you're talking about, is there are two answers. One, yes, if it costs a lot, you can afford to bring programmers on and everything, and tune it. But you get your efficiency by understanding the program, and that's why I see where the Rust Go type language are better than C++, which is just larding stuff over the crap that exists and sort of silting up to the extent that anything you want to do requires 3 triple upside down colons in a row, and then upside down it won't work. But if you really want efficiency, what I suggested back in the 60s was you build a little automatic chip factory that will turn your algorithm into chips. And that's what we do now with specialized processors.
Yeah.
By the way, my thesis was on the cloud back in 74. Was that, what do you think time frame was?
Yeah, I remember, just since we're telling stories, when I first worked for the bank, I had to maintain a program that had line. What?
Which bank?
Oh, I worked the Southeast First National Bank of Miami.
Okay. At least you were not at Fleet or Bank of America.
No, it wasn't. Well, it's now part of Bank of America.
Oh, everything is. You mean Bank of Italy?
Right. But I had a program that was, nobody in my group wanted to touch. And it had code that it had self-modifying COBOL code.
Yes.
Yeah,
So
it's called an alter statement.
Oh, the alter statement, yes. And
It was the alter return to such and such, and then execute. And nobody could understand it because this was on a Burroughs computer.
Mm-hmm. It's like the come from statement.
And the first time I looked at the program, I said, wait a minute, that's a Baller instruction.
What?
A Baller.
Oh, Ballard, yeah.
Register, IBM. What they did was, it was an accounting program, and they took it from IBM that was written in IBM assembler and converted it to COBOL. And those features were in there, and everybody that ever touched that program hated that.
Mm-hmm.
And they didn't understand exactly what that was. It was nothing more than a subroutine call.
Yeah. How did COBOL do subroutines?
What?
COBOL has procedures, right?
Yeah, you would perform in COBOL.
Okay, so it sounds like when you were getting into people who were translating COBOL the assembler mindset of the go-to rather than
It was done mechanically. They wrote
oh,
a disk.
okay. Oh, yes. That's yes. I could understand exactly. What somebody should have written was an interpreter for 360 instructions.
Yeah. So it was really, the code was where they had taken an accounting system that was written in IBM assembler, IBM 360 assembler, and they converted it to Burroughs COBOL.
Not Burroughs Algo, though, I guess.
Yeah, and the COBOL programmers I worked with hated that program. They gave it to the first newbie that came around.
And nobody thought of rewriting the thing to be readable?
But when I looked at I took a course, and I had learned assembler in graduate school.
Mm-hmm.
And so I learned when I first got to the bank programming, the bank data center, I studied IBM assembler.
Mm-hmm.
So that when I took over that program, I looked at it and said, oh, I know what this is.
Yes.
And
how good was the translation otherwise?
Excuse me?
How good a job did they do translating it? otherwise?
I didn't understand you.
How good a job did they do translating it otherwise?
It was almost line by line. It's not a very good job. It was done mechanically for most parts. Some was hand done. Depends on the program.
Yeah.
And so nobody liked that system.
I bet that program is still running today.
Could very well be.
It's just, again, how many of you have looked at the daily WTF?
The daily what?
The site, the daily WTF. Let me make sure I got the name right.
I haven't. No.
Not in decades.
You're so familiar with the site. We go find it. Oops, I missed it.
Sounds like something better back in the 90s.
There it is. It goes into it. Let me put this one back here. It might be too painful to look at some of the examples.
Yeah.
But yeah, but I mean, there is the problem I had even in the '60s was how is programming taught. It was taught sort of as mechanical skill, not sort of philosophical, intellectual undertaking.
Yeah, I learned to program in the 60s, but I went into the Army right after college and learned to fly helicopters instead.
It could be more fun, but
It was. Maybe not when you're getting shot at, but
okay. So
it
you
was
went over there. You went over there.
Vietnam was a really, really beautiful country.
Mm-hmm. Have you been back?
Excuse me?
Have you been back?
No. A couple of my friends have, but I have not.
We'll see what happens when quadcopters controlled by computers become the norm. It becomes too easy to fly them.
Yeah.
Well, I know I live in Sequim, Washington, and
Which Washington?
oh, Sequim, Washington.
Where?
Here, let me.
I mean,
Put up a
I
link.
used to commute to Washington, so I was curious.
Yeah. Let's see. You worked at Microsoft, right? Or did you work at an office in?
No, and there was no office here.
Oh, okay.
Development
you-
office was Richard Stallman.
My daughter almost slugged him one time.
One time?
My daughter was working as a waitress in Cambridge, and she almost slugged him.
I can understand.
But I was gonna say so I live about a couple of hours from Seattle, and
Couple hours, so that's more to us.
actually it's probably another half an hour that involves a ferry ride too.
Mhm.
Oh, so you're in the other direction.
Yeah, I'm just about across the channel from Victoria, BC. But I know we have a big supply chain issue here. There's a few big box stores where trucks show up all the time, and I think just recently, I think Amazon started. They built a warehouse somewhat near here.
Here?
Where I live.
Are you out in Washington now?
Yeah,
Oh, okay.
yeah. But I was gonna say, like,
Yes.
if like where I live, because we're farther away from the urban areas, like having unmanned drones, that we're able to move commerce to say like a warehouse here.
Well, look at this. Mark Rober has some great video about drones used for drug delivery in Rwanda, but also they're ahead of Amazon in developing the technology.
Yeah. But I think, yeah, like having drones that, say if trucks were replaced.
Well, actually, I know somebody will fly a helicopter there for you.
Yeah. Yeah, I think it's also because the housing prices have gone up significantly here. So people, for reasons, want to come out and move farther away to more affordable areas that and do remote work. But then one thing I didn't realize here is that I'm so rural that things like getting a doctor or finding a vet, like certain services are harder to obtain here because it's more remote.
Yeah, I see where you are. Yeah.
Yeah.
'Cause I did take a seaplane tour once. It turns out there's a seaplane that went from Seattle to Victoria, but if you took the round trip, it was a fraction the price of the one-way trip.
Mm-hmm. Yeah, I think there's a ferry that goes to Victoria, like one town over, but I haven't been there in a while.
Yeah, you just need to learn to fly. That's all.
I think housing prices have been going crazy everywhere.
Yeah.
I look around today and I see how prices like $1.8 million for something that 10 years ago would have cost $400.
Yeah, but at the same time, like I see, like with remote work, that you can find the remote, some place more affordable, albeit more remote. But
Yeah, Thailand is
I'm
very
saying
popular.
if someone solved those supply chain issues where, like say where I live could get the same amenities and services as like say if someone lived closer to Seattle, that'd make life a lot better.
Well, we'll see what happens with all that. Turn on the layers view. It's still pretty dense. It's still a pretty big area you're in.
Yeah, actually, the population.
Oh, there's a Costco. You've got a Costco. What are you complaining about? And a Walmart.
Yeah.
You've got civilization of sorts.
Somewhat, yeah, but like I said, but issues like I said, like finding a primary care doctor here took months.
Oh yeah, no, for medical care, yeah, this is the place to be.
Mm-hmm. Yeah, I have to say I guess RCN is part of some larger conglomerate, and we get cable from them.
Well, actually, here, separate issue I'll pitch to you. Are you connected politically there?
No.
Okay, because if you do, the town should just own its connectivity. Why are you having a foreign carpetbagger company controlling your ability to communicate?
No, my last house, I had a fiber. I was part of the county fiber network.
No, but you should just own its infrastructure. It should just be open. Yeah. Look at my packet, public packet infrastructure proposal.
Yeah. Now, before I lived here, I was getting symmetrical gigabit fiber for about $90 a month.
Yeah, I mean, but the point is, why it shouldn't be a per month charge? How much a month do you pay for your sidewalk?
Sidewalk?
Yeah, I mean, is there a turnstile in front of your house? Don't you have a sidewalk subscription?
I pay for my sidewalk. It's part of the square feet. It's assessed against my.
No, it's assessed, but you don't subscribe to the sidewalk and have a turnstile in front of your house.
Yeah, you're basically arguing that it should be utility.
Infrastructure, not a utility, infrastructure.
Careful, Bob. You keep saying things like that. Somebody might take it as a suggestion.
It is. I mean, sidewalk as a service? Well, we're actually getting there with roads. Now that we can do electronic car things, we're going to start.
And in Tokyo, and we're now selling oxygen in the grocery store.
Well, people buy bottled water. How stupid can you be? You know. But
towns, it's the last necessary.
Yeah, hopefully we'll get to the infrastructure point when telecom collapses, since it does not have a viable economic model.
Why some people still have landlines, and why are landlines more susceptible to scammers? then
That's because the conversation I had with Craig McCoy years ago. I said, look, Shelley has all these protocols. Why do you have them on landlines? He said, well, I don't make money on landlines. But my landline is a Google Voice line. Okay. Still get scammers.
Yeah, we have a landline, and the only time we use it is at my wife's phone. For some reason, all the calls that she was getting went directly to voicemail, even though we have calls over Wi-Fi. And so she started using that, but only in the case where if she doesn't get a call or something for a friend.
Well, I've Google Voice coming in OB High box over my Ethernet.
Yeah.
Okay, I think if people have any other questions.
Okay, I'm going to shut down the YouTube.
Okay. Hello, Bayo.